present on tourism research and online data. Thank you very much, Vic.
All right, thank you. Thank you for the nice introduction, Baron. First, thank you for coming. And Baron was apologizing to me. There's only 20 people coming or 30 people. You know what? That's plenty of people. You know, I once invited my advisor, Dr. Fezemeyer, one of the famous professors in Temple University, to my college. He gave a talk. There are only 3 people coming to the talk. So I feel much better now. So really my pleasure, my privilege to be here today. It's my first time in Australia. You know, I saw the beautiful coastline from the airplane. I had a nice walk from my hotel to the school today. I never saw a sky so blue, just like the blue background of this slide. Wow. I'm really impressed by the University of Canberra and the leadership and the vision of the faculties. So I hope we have further collaborations in the future. I know a lot of my colleagues are moving to Australia from US, from Hong Kong in recent years. Now I know why. The topic of my talk is tourism research and online data. I chose this topic because I consider myself half a computer science major. I took many courses in University of Illinois as well as Cornell. And I'm a data junkie and a geek, a computer geek. I love computers because I think it has this democratization power to people. Computer internet can empower people. So now we have a voice on the internet. Everyone has a voice on the internet. So basically, I will talk about 2 research here. One research focusing on connecting destination image with search engine volume. The type of keywords people type in search engines, especially on Google. The second study I'll talk about is about forecasting. How to use certain search engine keyword search volume to predict hotel occupancy in one destination. So the 2 talks combined, shows the power of online data. I think there's a rich resource of online data available online, and as researchers ourselves, we should take advantage of that. I will start with a story. Target knows before it shows. Anyone heard about the story? No? Okay, good. So Target, it's the second largest retail store in the US, just after Walmart. The story goes like this. So one day, a man rushed into a store and demanded to talk to the manager. He held up a brochure. He says, "How dare you send my daughter the coupons for baby clothes or cribs? She's still in high school. Do you encourage her to get pregnant?" The manager has no idea what she's talking about. He of course apologized, and he said, "Okay, it's our error. We made a mistake." And the manager actually later called his home to apologize again. But this time, it's the man who was abashed. He said, "I'm sorry, I should give you an apology. There's some activities going on in my house I was not aware of. My daughter is due next October." So Target knows before it shows. So how Target knows that? Because Target has a data mining team in the company. Every time you went to the Target store, you made a transaction, or you go online to purchase item, you'll leave a trace of your information there. So one data mining team member found out, toward the second trimester, the pregnant women will buy a lot of unscented lotions, and later they will buy a lot of cotton balls. When the due date approaches. When they combine the data together, when some women start buying a lot of cotton balls or unscented lotions, they know a baby is coming on the way. Okay. So that's the power of data mining. So because these days, every time you're online, you visit some web pages or you make a transaction, you leave a trace there. The traces contains a lot of your information. And combined, you can know a lot about consumers. This story tells us two lessons. First, data mining is powerful. And the second, of course, there are private concerns. Right? The second is we need to be careful on what to reveal we know about a customer. It can really creep people out. Right? Think about this, especially in terms of tourism. There's explosion of big data these days. So every time you go on search engines, you go to Google, you type in a keyword. Google server captures your query, captures your IP address, captures the time of your search. And the IP address tells you a lot about the location of this person, and also the organization you're in. And we all have location-based mobile devices. Every time you go, your phone, you can tell your location by either GPS or the power of the mobile phone company. Software logs, we never use the software, use the app. They kept the trace of your activity. Website traffic. Every time you go to a website, the web traffic captures your IP address and time and the location. And we all have cameras with GPS, RFID tags, and I think Baron did some study on that. And Hong Kong has the ID card you can use in the public transit system. And you can also buy a lot of stuff using the ID card, which is RFID tags. Right? That captures a lot of information about the consumers. Even medical exam records, if it's digitized, you have a lot of sensor networks in the buildings or bridges. Of course, you have all the satellite on the sky capture all the movement. So there's a big explosion of data. And data is important, but unless you combine it with those tools, because there's too much data these days. But if you have data mining tools, you can use some artificial intelligence method. You can use some scientific analysis, maybe on tweets or blogs. And you can link different databases together. You can know a lot about consumers. This picture shows IBM Watson. It's a supercomputer win the Jeopardy Award in 2011. So anyone knows Jeopardy Award? I'm sorry, Jeopardy competition, like a quiz show, yeah? You test people on different, piece of knowledge on pop culture or whatever. So this shows this not only based on the the natural language processing, but the parallel computing of supercomputers. So they use the brute force of fast computing to solve the problem of finding specific information. So you combine big data, you combine with these tools, you can really gain intelligence. And that gives us a lot of opportunity for design, better technology for the future, and for tourism. So the first study I'm going to talk about is how to use search engine data to understand information source behavior and the travel intentions. So basically, I'm trying to connect destination image study with the search engine marketing. The study is published in Tourism Research last year. Study is done by me and one of my colleagues at the University of South Carolina. The title is called The Long Tail of Destination Image and Online Marketing. Okay, so I'm going to do some borrowing information here about review of literature. So we know that destination image study is one of the most studied area in tourism. Basically, we study tourism image from a branding perspective. For example, how do we compare Australia with New Zealand in terms of destination image? Then it can give us some idea on how to do further branding, how to change people's image about this destination. And we can also measure image after a marketing campaign, say how we are doing in the marketing campaign. Are we making difference, right? That's use of branding studies. So we always report the most commonly held image about one destination. So for example, China. So when you think about China, what do you think of? What keywords popped in mind? The Great Wall, thank you. What else? What? Big cities, yes. See, so those are the commonly held image about China. So usually we study the commonly held image of destination. Either use a structured approach, which means we measure on scale of exciting, how exciting this is, or how peaceful this is, or we measure through unstructured approaches, such as give me 3 words about China, right? But the challenge is the so what question. So we know people know about China, about Great Wall. I mean, so what? How do we improve on that, or how can we use marketing on that, or how do we deal with those little images? For example, maybe people will associate China with, I don't know, panda or Yangtze River. How can we use that information? Right. So if we connect the destination image study with search engines on information search, we can get some new ideas. For example, we know travelers search information and generate the keywords based on their mental models. So that's my shameless self-citation there. So destination image is part of the mental model when people searching online. So our assumption is the phrases describing a destination image may be linked to the keywords travelers use to search online. So image items might be those search keywords on Google. Well, that's the assumption. We're going to test in this study. With things goes online, follow different rules. Have you heard about the long tail theory? Long tail theory, yeah, yes. Good. So for those people who are not familiar with long tail theory, it's a term coined by Chris Anderson. Chris Anderson is the editor of Wired magazine. So he argues that our business follow this long tail graph. So basically, so the x-axis is the rank of your product. The y-axis is the volume of sales or revenue. So basically, a few popular product can generate a lot of revenues. And you have a lot of niche product and generate very few sales. Right? So this is like this so-called 20-80 rule. 20% of product generate 80% of revenue. Right? So when you look at the companies or the industry or even earthquakes, follow this kind of curve. It's called a power law distribution. So a very big, very few heads, have a lot of sales, and a lot of niche product have very few sales. So Chris Anderson argued in the online world, the rules changes because in a traditional store, traditional business, you're focusing on the head, and you cut off from here because it doesn't make sense to focus on the very niche product. If your product only bought by 2 consumers, you might not produce that, right? So traditional business focus on this part. They have cut off right here. For example, Walmart. Walmart only carry maybe around 4,000 songs on CDs, right? When you compare to Rhapsody, which is online music service, you carry 1.1 million songs. So why is that? So because Walmart has a storage cost, has a labor cost to reshelf stuff, and the Rhapsody is online storage. It's virtually free. So basically, the online business can generate more revenue from these tails than the head. Amazon make more money by selling unknown books than selling popular books because the cost of storage transaction is low. The movie theaters carries maybe a few hundred movies every year, but Netflix carry a lot more than that, tens of thousands of movies because the cost of storage is low. They can afford to sell to the tail. So this says the importance of a long tail. And then if we translate into image study, so should we focus on the popular images, or should we focus on the niche images? Right? So that's our question. Destination should mainly understand, improve, and project common or popular images, or we should focus on the tail. If people really use those niche keywords to search, maybe we should focus on the tail also. Maybe we should focus on Kung Fu China or Panda China or Yangtze River China when we do marketing online. So the basic, two goals of the study is we want to examine if destination image follow this long tail characteristics. We like to look at the head, the most popular keywords. We want to also look at the niche keywords. We also want to connect the a destination image with search engine marketing. Do people use those keyword phrases to search for China? We have two sets of data. One set of data is from a survey study down to about the American population. It's not census, but we have a demographic balanced responding to study their image about China. The second set of data is search engine volume. So Google provides some tools. We can see how many people search for the word such as the Great Wall, China, or the big cities, China, or Shanghai, China. First, the survey. The survey is a project supported by CNTA, the China National Tourism Administration. It's a project work with Robert Lee in University of South Carolina. We did this in 2008. We used an online panel about American adults, 18 years old or plus, who took actually one leader trip in the past 12 months. We demographically balanced the respondents with the TIA data, which means those people who travel abroad. We have more than 3,000 valid responses. We use 3 open-ended questions to address those images. The first question is about the overall image. What 3 images or characteristics come to mind when you think about China as an overall image? The second is a factual image. How will you describe the mood, the atmosphere of China when you think about China? Right. The third one is a cognitive image, which means list 3 distinctive tourist attractions or cities or provinces you can think about China. So they have to fill in at least 1 items. They can fill in up to 3 items each. We did data cleaning. We did frequency analysis. We modeled using power law distribution. We associated with the number of respondents for them, how many respondents use these 2 keywords. And then we link with Google search volumes data. And we also associated the niche data for phrases with their intention to travel to China. Which means if you use the phrase, the very niche keywords, are they more willingly to travel to China? Okay. So here's those phrases. Of course, the Great Wall, used 740 times. Crowded, that's almost 400 times. Food, culture, communism, people, of course. So that's the top keywords. The middle keywords are food tasting, food unsafe, forceful, foreign lands. And the bottom keywords are yummy, yuck, yin yang, ear of the dog. So the total is more than 8,000 phrases, but they have only more than 1,600 unique phrases, which means there's a lot of unique keywords appeared. That's for the overall image. 3 images or characteristics in your mind when you think about China. The second is the factual image, like the 3 keywords about mood, atmosphere. First one is exciting, that's 600. Happy, that's less than 600. Then busy, interesting. The middle ones are somber, apprehensive, which means the middle one, which means appear in the middle of the frequency rank. The bottom ones are wishes, filled, withdrawing, wondering, worldly, wow. So in total, we have almost 8,000 phrases. The unique phrases is more than 1,000. The last one is the cognitive image, which means those attractions or cities, provinces you can think of. The Great Wall, again, the first one, then followed by Beijing and Hong Kong, Shanghai, Forbidden City, Tiananmen Square, temples, Olympics. So that was because it was done in 2008. So Olympic Games was held in Beijing. The middle images are Yangtze River, Tibet, Buddhist temples. The bottom keywords are shaman, Xiaoxing. I don't know what that is. The total images is less than 6,000. The unique phrases is less than 500. As you see, people have a lot less content image to describe China. That means they may have less knowledge about China. Right? Any questions so far? Feel free to raise questions. I tend to talk faster and faster. Remind me to also. Okay, so here we plot those keywords on the graph. So here is the rank of the keywords, and the y-axis is the frequency, right? So as you can see, the top phrases have a lot of volume, and it slowly dropped, right? So top 34 phrases capture half the volume of phrases for overall image. For effective image, top 25 phrases capture half of the volume of phrases about effective image. Content indicators, actually top 3 phrases have half the volume. So Great Wall, Beijing, and Shanghai is half the volume people describe destinations about China cognitively. And please note that I only capture the top 10% of the keywords. That's really a long tail right here. Because the tail is too long, I cannot show them on the graph, so I have to cut right here. So it is power law. This looks pretty good power law to me. If you do the log transformation, so basically if this is a straight line, which means it follows power law nicely. So as you can see, it's very close to a straight line, which means it follows power law distribution. There's a few keywords, very big, used by a lot of people. There's a lot of niche keywords used by maybe 1, 2, or 3 people. So those keywords follows power law pretty nicely. For all this overall image, effective image, and cognitive image. Of course, we have the regression. We use log transformation to regress on this. As you can see, it's highly significant. So R square is, above 95%. So let's follow power law. So this is the equation for power law. So X is the rank, is the rank of the keywords. Y is the volume. As you can see, follow power law pretty nicely. Then we look at the top phrases covered, so which means so this graph shows if we look at the first 2 phrases, how many volume is covered, how many respondents covered. Okay. For example, the top 2 keywords for our overall image is only 0.1% of all the search keywords, but they covered 14% of all the phrases, covered maybe more than 40% of respondents, which means 40% respondents use one of the 2 keywords. Okay, so you can see the pretty good 20-80 law. So 20% of phrases cover 80% of the volume. 20% of phrases cover 80% of volume. For the content image, 20% of images are cover 92% of volume, which means there's an even bigger head. So concentration on the head. Okay. So basically, this shows it follows power law. It follows the 80-20 rule. It's a very fat head. It's also very long tail. And for the content image, they also have even fatter head. Of course, these are the image phrases, but do people really use those phrases to search? So basically, we use a tool called a Google Search Keywords tool. So this tool allows you to look at the search engine volume for certain keywords. If you play with Google AdWords, you know this. So basically, you type in Great Wall China, it shows you there's 100,000 searches last month on Google on these keywords. There are 450,000 searches monthly on average in the past, 6-7 years. As the global monthly searches versus the local monthly searches. We can correlate this search volume with the volume of images in the respondents reported. we found out actually the correlation is pretty high. It's, yeah. Yeah.
Those keywords specifically from American searches?
No, globally.
You built American data to correlate?
Maybe we should. That's a good question. Yes, but my guess is it will be highly correlated because I think more than half the volume is from U.S. Yeah, but that's good. That's good question. Yeah, we should have done with the American search volume. So we did a Pearson correlation of 0.65. As you can see, a lot of the searches for the top keywords also are the keywords appeared in the image phrases. We added China here because in the survey, China is implicitly indicated because that's a survey about China. We have to add China in the keywords to get the correct search volumes. So the top phrases search a lot. The bottom phrases search very little. So we proved, people do use those keywords to do a search on Google. Then we want to link the distinctness of phrases to travel intention. We want to see if people who are using those niche keywords are more willingly to travel to China. We have to first define the concept of the distinctness of phrases. What do we mean by this? We define this by the reciprocal of the probability that you will encounter a phrase in a text corpus. For example, if there's a text corpus of either 1,000 phrases, if a phrase appears 100 times, the value of distinctness is 1 over 100 over 1,000, which is the 10. So basically, more unique the keywords, the higher the value. So we average the 3 phrases for each question. We get the average distinctness value for each respondent. We correlate that with the travel intention in the survey. Okay? So first, we have to get those covariance. So basically means we control those ethnicity, age, number of word area visited, whether or not they visited China, or gender. So those variables we found out also determines travel intention. So we have to get rid of those influence first. So we control for those variables. We found out the distinctness of a unique image is highly correlated with the travel intention. So the phrases they are using to describe China, if they're unique, the more likely they will travel to China in terms of attractions, cities, province. That after we get rid of the influence for travel history or travel experience. It makes sense. If you know a unique province or city in China, you're more likely to have more knowledge about China. You have interest in China, right? Either from books or magazines or TVs. So basically, those people who are using niche image about attractions are more likely to travel to China. So what's the overall conclusion? We showed the destiny image Americans are using to describe China also follow a power distribution. Certain attributes or attractions are known to many of the respondents, but thousands of niche phrases contribute a large volume. Right? Those are the long tails. Because think about the marketing. If you do a traditional marketing on newspaper or TV, how many concepts you can deliver in one marketing message? One, right, exactly. One, maybe 2 at the most, or 2 or 3. Right? That's only capture less than half of the volume, less than half of the respondents. That's very limited. So we showed destiny image actually leads to such keywords, and niche keywords lead to high intention to travel. So in search engine marketing, instead, we should targeting both head and long tail in search engine marketing. Because when you are bidding on keywords, you can bid on as many keywords as you want. Remember, if you use Google AdWords for search engine, you can have thousands of keywords. Doesn't matter. And we show the people using these keywords are more likely to convert. Right? So the head of the long tail curve is useful for traditional marketing. So maybe we sort of project the Great Wall or Beijing or Shanghai. But when we do the search engine marketing online, maybe we should focus on the long tail. Right? So overall, this study shows we really linked the search engine keywords with the mental model of people, the destination image. And we also showed those image items, the search keywords, represent the travel intentions. So we showed the value of this one type of online data, which means the search engine volume. So the next study actually I'm going to talk about is we actually link search engine keywords with actual travel behavior. Yes? Yeah.
I'm interested in the sampling used online, an online panel.
Yes.
Did you ask, that you have an equal mix of gender, of ages? How did you?
Yeah, that's a good question.
Is your sample representative of the travelers to China?
That's a great question because we know online panel may represent a different population, the people who respond to surveys. So we basically, we use another survey, which is a study done by TIA, which is the male survey. This study the people the American travelers. They get the demographic data for average American travelers, their age, income, and regions of the population. So we balance this online panel data with their data.
So you asked?
Yeah, we asked their.
The company to.
Yeah, the nice thing about online panel is they only charge you if anyone responded. Yes, so we can give them the variable. See, this is our variable we are looking at. Please balance. This is money of a female, this is money of a male, from this place, from that place. So they can do that. Yes.
On a similar way.
Yeah.
Would you consider some of the demographic variables? I've seen that the ANOVA shows that the statistically significant is very high.
Yeah. Yeah.
Introducing age, ethnicity, and gender as the intervening or moderating variables? I think that would be interesting.
Yes.
For compiling and segmentation problems.
Exactly. So ethnicity might be one. If you are Chinese descendant, maybe you're more likely to travel back to China. I don't remember if we capture ethnicity. If we do, I'm sure I did some correlation on that. If we have not, that's really a good idea. Yes, I think that might be influence. Yes. Yeah.
Talking about associating China to different sort of images,
Yeah.
have you considered negative and positive messages or images? I just noticed you had the word yucky. So how about such an image and its relation to the intention?
Wow, that's a good question. Yes. So people said yucky about China. So we're marketing on yucky, right? Yeah. So you're right. That's a good question. I haven't looked at that yet. Yes. So I guess that's the way. How do we use? How we marketing China based on the positive image, right? Maybe how do we correct the negative ones? Or maybe we should look at the ratio between positive and negative ones. But we haven't done that yet. But it's a really good question. Yes. Yeah. And also people make erroneous connections of China. For example, people talk about sushi China. Or karate to China. Karate is the karate. Neither karate or sushi is such a China, but how do we correct it right? Right? That's a good question. Thank you. Yeah. Maybe it's the next study. Any more questions on study? Okay, the second study basically we're trying to connect search engine keyword volumes with actual travel behavior. Remember, the first one is about information search and also intentions to travel. The second one actually we're trying to connect between search engine volume and the actual travel behavior. So this study was done by Dr. Song in Hong Kong Polytechnic University, and one of his students published this year is forecasting hotel room demand using search engine data. The study actually is from I got the inspiration from a Google Flow project. Anyone heard about the project? Except Baron. So the paper is published on Science. So basically, a few scientists from Google, they published a paper. They trying to predict flu outbreak using the keywords people are using on search on Google. Hear about this? You know me? No? Okay. So think about this. When you have flu, more likely you go online, search for flu symptoms, or the medicines for flu, or even recipe for chicken soup maybe. Right? So those keywords actually indicate how many people got a flu virus. And the people more likely they are go online before they actually go to see a doctor. So that's the value of search engine data. They can be a few weeks ahead of a curve. Think about this. In the past, United States rely on the CDC report, the Center for Disease Control, to monitor flu outbreak. So that's based on report from the doctor's office, from the hospitals. That's after the fact. And after so many people got flu already. Right? That's already been late. As you can see, the Google Trend estimate is closely correlated with United States CDC data. And actually, they have a video on this. I'll show this video. It's a very quick video. Oops. Let me replace again. Okay, so here's the video shows how nicely it monitors flu outbreak. The blue line is Google flu in the data. The yellow line shows the CDC report. As you can see, the CDC report is always 2 weeks late. So it's followed pretty nicely. And 2 weeks time is a pretty good deal. It's a big deal, for monitor diseases. Think about this. So they have more time to maybe stock up the medicine, stock up flu shots before CDC detect a flu outbreak. Okay, so the Google flu trend is not only used for detect flus, also for detecting who's more popular, Lady Gaga or Justin Bieber. We can see how many people search for those two celebrities. So what do you think? Who's more popular? Gaga? Good guess? Justin Bieber? With the answer gender, yes. But see, in total volume, who's more popular? So someone said Lady Gaga and Justin Bieber. Bieber, yeah, okay. Right, that's a good question. Yeah. So basically, I type in those two keywords in Google Trends. You can do that right now if you want, have a computer. Here shows Gaga, the red line. Here shows Justin Bieber. I love using examples in class. Yeah. Kids love it. But it's hard to find a proper picture from Lady Gaga. So yeah, see, Lady Gaga's reputation from early 08 and reached the height point maybe in early 2010, and slowly dropped down. Justin Bieber, a little bit slow start. Of course, he's young, and he reached the peak in 2010. And also right now, so Justin Bieber is more popular than Lady Gaga. Maybe because Baron said the young people tend to search online. So actually, if you go to YouTube, the most popular video on YouTube is Justin Bieber, yes, a baby, right? And the Lady Gaga is maybe like the second or third videos on YouTube. So, well, we can use search engine data to predict flu outbreak. We can use search engine data to see the popularity. Or we can use search engine to predict hotel occupancy. So yeah, if I type in, Charleston, SC, South Carolina in Google Trends, I can see this. That actually matches the seasonality of Charleston as a tourist destination. So the peaks in the spring and the summer and the fall, there's very slow in the winter. So now we try to use this data to help to forecasting hotel demand in Charleston area. So past studies, of course, shows search engine data can predict retail sales, automotive sales, home sales, tourist arrivals in Hong Kong. That's done by two scientists from Google. They also can predict unemployment and claims and unemployment rates. But basically, when you lost your job, the first thing you go online is to say how to draft a resume, or how to how to find an unemployment office, right? So they have shown Google data can predict unemployment claims a few weeks ahead of the curve. So I try to connect this searching data with tourism forecasting. The past forecasting has focused on tourist arrivals, expenditures, or night stay. They use independent variables such as population of the origin place and a destination place, use income of the two places, exchange rates. We know exchange rates affect arrivals, tourism product prices, consumer taste, marketing expenditures for DMOs. Then you can use linear, nonlinear regression, econometric models, or neural networks to predict. Mainly they're focused on quarterly or annually forecast. You see that all the forecast mostly is quarterly or annually, very few monthly forecasts. Right? So it's very low frequency. So this time we're trying to forecast weekly hotel demand. Can we forecast weekly hotel demand using search engine data? Because search engine data you can get daily data if you want from Google's trained on Google Insights. Because the hotel occupancy data is so crucial. I have an office called Office of Tourism. We are working with the local the CVB, the Convention and Visitors Bureau, closely. So we report to all the hotels their past week, what's the average occupancy in this area, and what's the average daily rate for the hotels. And the hotels love that because then they can benchmark their performance with all the competing hotels. So the industry really needs this type of data, and they need a low, high frequency, such as weekly or daily. So we get the hotel data from STR Research. So STR Research is a company in the US. They collect all the data from hotels. Actually, more than 60 to 70% hotel join the program. Basically, they report their daily occupancy, daily rates to this company. The company aggregates the data and report them back to the company. Of course, they keep the individual hotels' privacy. You just say, in downtown Charleston, the average daily rate is $150. Average occupancy is 75. Right? So they have a pretty good sample. More than 60-70% hotel participating. So we collected those 81 weeks of data on hotel occupancy and hotel demand. Actually, we use hotel demand, which means total room sold. We use first 60 weeks as the training set to gauge the parameter. We use the last 21 weeks as the validation set, see how accurate we can predict. So I'm going to go into very technical detail here. I will be the last person in this room. Admit I'm an expert in econometric modeling. So basically, I'm still learning. I rely on my co-authors, collaborators on this. But I will give you a brief idea. So we use 5 queries. Search volume of 5 queries: Charleston, IC, Travel Charleston, Charleston Hotels, Charleston Restaurant, Charleston Tourism. So those are the most commonly used queries for a destination when people search for destination. That's from another study. So we use the search volume for those 5 queries. One thing I need to mention is Google Insight or Google Trends, they do not give you the actual search volume. They do not say that's 1 million searches. They will say they give you relative scaled volume. Basically, they pick the highest point at 100. They scale all the searching volume according to these highest points. So you don't know the actual search volume. You only know the scales. You can see up and downs because they want to protect the privacy of the searches. Because you can easily re-engineer, back-engineer to the individual search if you want. So we plot the log transformation for those data. So the line on the top shows room demand. Here on the bottom shows the search engine volume for those keywords. As you can see, you have similar drops here, similar drops here. Seems like they're correlated. Why do we use log transformation? Because we want to stabilize the variance. Because if you don't have stabilized variance, it's hard to use some econometric models to predict. Then we plot the data, and we use traditional forecasting methods. So Again, this is very technical. I'll briefly explain here. So we forecast, traditionally people use the last few weeks of hotel demand to predict the current week's demand. Okay? And that's AR model. ARIMA model actually is used the difference between this week and the past week. So sometimes because those data have is not linear, have a unit roots, you have to use the differences so that predict the difference between this week and past week based on the difference between the past few weeks. So in simple terms, and also the error rate for my previous forecasting. If I made some mistakes, if there's an error in the past few weeks forecasting, I try to adjust the errors in this week's forecasting. Okay. Of course, then we add in the actual variables there, which means the search engine volume. We want to see if those search engine volume help us predict the data. Remember, the previous slide shows only rely on hotel demand data in the history. Now we have the actual data X as the search engine volume for those queries. So add these queries in this model, in the next model, or in the third model. So we're trying to see which model will do the best job in forecasting. We also compared those models with a few more models. I won't go into detail here because those are the popular models for forecasting hotel demand. Again, the X variables here is additional search engine query data. If you're interested in the details, technical details, I give you the actual paper. We measure the performance by MAPE, the mean absolute percentage error. Basically, we say, so YT hat is the forecast value, the YT is actual value. We see we calculate the differences over the actual value, and we average them. We take the absolute value, basically how accurate, how much mistake we make. Right? So we want a lower MAPE, because the lower is the MAPE, which means we did a pretty good forecasting. Right? So this RMSP is different version of MAPE. Basically, it's squared again, and then they did a square root of everything. So similar idea. Okay, here are the results. Naive model, which means we predict next week's data based on the previous week's data. That's 7% error rate. So we 7% error rate, right? That's pretty good too. AR is 9%, actually even worse. These are different models. These are the traditional models. These are the models using the actual variable. You can see here we increase accuracy by maybe 3%, -3%. This one increased by also maybe 3%. This maybe 2 or 3%, right? So actual variable help us to predicting the hotel occupancy. If we compare those models with 3 more popular models, also which shows the ARX model is the best. We reduce the forecasting error from 7% to 5%. Maybe that's not impressive, but it's considering only 5 queries. So that's basically that study. So the basic says additional search engine volume of 5 keywords can increase forecasting accuracy by at least 2 or 3%. Remember the Google flu project showed you on the first, predict the flu outbreak. They use 45 queries. And they use the raw data from Google because the scientists are from Google. They have access to the raw data of Google. So we only use 5 queries. It can increase by 2 to 3%. We are thinking maybe we can add more keywords, volume data in the future, and we want to achieve the really accurate near future forecasting. So next time when I sending out the report for my local hotel industry partners, I have the data on past performance. I want to have the next few weeks forecasting. Right. So I'm sure they will love that one. Right, because they will just price their strategy based on the forecasting. So a recent study we've been doing is we're using DMO website traffic to predict hotel occupancy. Actually, we showed again the DMO website traffic can help to predict hotel occupancy. Because when you go somewhere, you are trying to come to Canberra. The first thing I do is go to Google, type in Canberra. And also I go to the local DMO website that predates actual travel dates. So my study shows it's 4 weeks. So basically, people usually search information 4 weeks ahead of the trip. So combined, the two studies shows we can link search engine data with information behavior, the travel intention, and also actual travel behavior. We can provide instantaneous feedback. So that's concept important. Imagine after a week or day, I can know immediately how my company is doing, or my destination is doing. That's instantaneous feedback. So the company or the business can be more agile. Not only a company, but the whole destination can be more agile. So I can change strategy immediately. And those data give us this opportunity. Not only search engine data, but how about the tweets? How about the Facebook post? How about the likes, dislikes? How about the blogs? How about scans, sensors, and cameras? These two, Bowling and Morehouse, shows they use tweets data to predict stock market movement. But basically, they calculate those emotional keywords like sad, excitement. They found out those keywords volume predict the stock market movement for the next few days. Now it's time to make some big money. Right? And many of those platforms has API available, application program interface. I tried this, it works. Even though sometimes if they don't have API, it's easy to do screen scraping or web pages using some programming techniques. So I really see the future for a system aggregation and analysis of multiple data sources and provide instantaneous feedbacks. I was brainstorming with Baron yesterday. We can really build a website with a monitor of the health of tourism industry from all those data. Here's the forecasting for next quarter. Here's the forecasting for next week. Here's the forecasting for tomorrow. Just like a weather forecasting. You can say it's raining tomorrow or it's sunshine tomorrow. How wonderful that would be. So I do see a future of smart tourism based on online data. Think about this. We can use so many data. We can create optimal experience with location-based device and intelligent, recommendation systems for tourists. For businesses, we can monitor their performance. We can tell them about the market. We can tell them the customers' wants, needs, and satisfaction. For local communities, we can monitor the natural and historical environment. Because Charleston, where I'm from, is a historical city. The people are keen on historic preservation. And because Charleston expanded their, cruise ship terminal this year, there are a lot of complaints. You're destroying our historic heritage. The city has been destroyed. There's a lot of parties involved. The question is, are we really? If we use some data, we can monitor that. Do people have reduced satisfaction for the city? Overall, I see this fourth paradigm. This is a book published by Microsoft Research a few years ago. We're talking about stages of research. The first stage is empirical research. That's been going on for thousands of years. So we try to describe a phenomenon. People coming to Canberra, their age, gender, where they're going. That's empirical. Second is theoretical. Then we can build a model. We can say the gravity model of tourism flows. We can build a model called a destination life cycle theory. Then we can use hypothesis when do some testing. That's the second theoretical stage. Then third stage is simulation. If we have too many variables, now we have to use simulation to capture all the interconnections. You can use agent-based or model-based simulation to see if test our theory, if it's right or not. The fourth paradigm actually is data exploration based on big data, lots of data. One example is astronomy. Today's astronomy, astronomers do not using a telescope. to see the sky. Actually, they are using a telescope, but using a digital telescope captures gigs data, multi-gigs data every day. They have to use a computer program to process those data. So they're not observing with their own naked eye. They're observing data using computer software. The future of research, I think, is going to that direction. We have so many data available. We will use software to process those data. We see the hidden trends. We see the predictions. So that's because of the fourth paradigm. First paradigm does not mean those first three paradigms are obsolete. We're still using that. But this first paradigm gives us more opportunity. I will end my talk with a story about Jeremy Lin. Anybody heard about Jeremy Lin? Okay, so Jeremy Lin, basically, he's a Harvard graduate in 2010. He was the captain for Harvard basketball team. But he was undrafted for a few years. He was undrafted by Golden State Warriors. He was undrafted by Houston Rockets. Then transferred to New York Knicks. He was on the bench for the whole year until February this year. Exploded. See, he scored 38 points versus Kobe Bryant. They created a phenomenon called the insanity in the U.S. So all the experts bypassed him. All the experts, the headhunters in Houston Rockets or Green Warriors, bypassed him. But this person is a FedEx driver in Oregon. He did a few graphs based on the statistics. He predicted in 2010, Jeremy Lin will be a star in the NBA, while he's still in Harvard, playing for Harvard basketball team, just based on the statistics. So numbers tell the true story, because human judgment are erroneous. We have so many different biases we didn't even know of. Maybe because he's Asian, maybe because he's only a meter 91. So that's a lot of potential for data, a lot of potential for big data, a lot of potential to develop this system to be smarter. Okay, so I think that's my talk. I'd like to welcome some questions. Yes.
In discussing measuring or calculating the capacity, the cell capacity.
Yes.
So did you consider information coming from other channels like call centers, offline branches, because these other channels will necessary for information in order to.
Right. That's a good question, because we found out only 20% of people come to Charleston using Google from the survey. So we should have used computer data or other data. That's maybe the next step. So the first step, we want to prove these links exist. Now we can add in other data. So yes. It will be realistic, yes, because some people call CVB, the Tourism Bureau, to obtain the brochures. They're not going online. And Charleston is a city which a lot of senior people come to Charleston because it's historic. Yes, that's a really good one. Yes, we should consider those, either online or offline. Yes. Yeah.
My question is more in the region of ethics using the data.
Yeah.
For